really like this application. Playing with it has been super fun. And today we'll get our hands dirty and get this running together, and we'll have a look at it. And from now on the upcoming chapters, we'll be actually doing everything using this application.
Yeah, this is the skeleton app we talk about.
Yeah,
Skeleton, walking skeleton.
The walking skeleton,
Now I call it
which
the
has been
skeleton
a
app.
bit, yeah, a really good representation, description
Yeah,
of what you should have if you want to play with the
it's
technology, if you want to dive into, learning
microservices.
something,
Yeah,
microservices. That's a
it's
great
split.
example.
Yeah, it's split into microservices, and each microservice depends on a stateful workload like Kafka and Redis. So it's a good sample app if you're getting started in
Yeah,
Kubernetes, how to
yeah.
deploy this app.
So this chapter will be covering working with a cloud native application, which is our conference application. And we'll choose between local and remote Kubernetes clusters here, like understand actually how to pick a Kubernetes cluster for development purposes. Obviously, you can't use a local Kubernetes cluster for production, but we'll understand, the pros and cons on having those. And we'll take a look into the main components of Kubernetes resources and understand what the challenges could be, like what we are expecting from cloud native applications now, how the industry pushed us forward from having monolithic applications to microservices, and how the resiliency and uptime expectations changed, and how Kubernetes reflects all those actually needs coming from businesses. So, but first, we need to get this application up and running. Okay. So yeah. First, we'll have a look at the Kubernetes environments actually. So you can have local Kubernetes in your laptop and desktop. So this has been something I used a lot for learning. I used Minikube, I used Kind. These are all very common tools within the industry. You can also use some services like Killer Coda that provides you a limited cluster service, like limited time. For a limited amount of time, you can use a perfect cluster for testing purposes, for playground purposes. So these are like fairly accessible on any browser you have. It doesn't have to be a like exam purpose. You can also use any playground here. And then, oops, let me close this one. Yeah. So local Kubernetes pros will be lightweight. You will be able to get it in no time. You won't be dependent on anyone else. You won't be dependent on and you won't have to pay. That's one of the pros, right? Cons, it will be not like a real cluster. It will behave differently. Networking will be a little bit different, and you will have to switch your mindset a little bit going to production when you're deploying to an actual Kubernetes cluster. And so, yeah, you can ask for if you have on-premises data center, you can ask for a Kubernetes cluster there for dev or sandbox purposes. So yeah, pros will be like you will be playing with a real cluster. You will see how the production environment might behave. But cons will be like you will probably be getting this from an operation team that it might take time. And you can also pick managed services on any cloud provider. And for this, there is a great repository Marissa shared here. But before that, let me just read this little section. So you need to choose one cloud provider and have a credit card ready. You can get free credits until you run out of these credits. Nothing is debited from your credit card, but be careful. You have to give your credit card information, obviously. So everything will be remote, and so it will actually be like almost like a production environment for you. But yeah, you need to be careful about the costs. And then you can also use playgrounds elsewhere. And this is a very great link here. So Mauricio apparently collected all the free Kubernetes offerings from actually credit offerings from different cloud providers, and how these are applied, like how much credit you can get once you signed up, and what you need to do, and how it behaves after your credit runs out. So there is a very long list here if you want to check. So yeah, we had a short, look into the pros and cons of having these dev environments. Here we'll be using Kind, which is a very common one.
Very
And
common these days.
yeah,
I'm surprised. Back 3-4 years ago wasn't that common and becoming
yeah,
more
it was
common now.
Minikube, right? More common.
Minikube, yeah.
Yeah, exactly. So I won't go into too much detail because later in the chapter we will be talking about all the Kubernetes components. But in this application, we have deployment, services, ingress, and persistent services, and their databases in the back, and Kafka to manage events between services. So even though it's a small walking skeleton, I think it's a great example to play with. So as you know, or if you don't know, you will be learning now. There are ways to package and install Kubernetes applications. So one is templating engines, and the other one is package managers. So it depends on what you need to deploy your application, but both of them are very common, and you can use either one. So templating engines work like you define a template for all the environments you have, but for each environment, the templating engine actually replaces all the variables and variables you need to change for a specific environment. So you won't have to deal with dev YAMLs, test YAMLs, all sitting in the same folder. You just have one template for, let's say, the service YAML, and the templating engine deals with that for you.
Yeah, Helm, Customize are the two top options
Yeah,
that I see in the field, and Helm is becoming, at least in my where I see in the field, is becoming more not popular but most used because everybody shared their software through a package through Helm,
yeah,
and it's versioned. It's more portable. You can put it these days in a OCI registry, the
yeah.
same place that you put your container image. You can also put your Helm chart.
Yeah, image registries can be used now for Helm packages in the OCI image format. And actually, Mauricio's application repository was also sitting in Docker repository as well.
Yep.
So we'll be seeing this. And yeah, you can also use Helm or other, package managers for Kubernetes, but the Helm is like is the most common used one. And for this, you can use semantic versioning, which will help you actually manage your versions like a proper application package would do, right? And so you can use some repositories like Maven, Central NPM, Docker Hub, like Carlos mentioned, GitHub Container Registries for OCI Helm packages. So here are the two other options for Helm. These are both from Carvel Dev, and one is CAP, one is image package. Okay, let's try to install our application now. So let me go to GitHub, or yeah, I'll do it here.
Oh, you're planning to install it? I didn't know you're planning to have demos.
Yeah.
Oh, that's a surprise. That's a big surprise for everyone. Wow. Okay.
I think it's fun to do it, because also it's how the book takes you forward with,
Yeah, so people, so then we can make a part of people come back next week and so on, like try yourself, right? Kind, like this kind is the only thing you need is like Docker desktop, and then kind is it's very small container. So yeah, play along and then put in the chat if you already tried, right? And then next week we'll go with the next phase.
Okay, the sharing doesn't switch to my VS Code. Let me try to fix this. Yeah, okay, I always forget the entire screen option here. So this is, guys, so I got the GitHub repository on the book, which is sitting here. It's the second chapter. Ah, thank you. Someone's praying to the demo gods. Lovely. Okay, so this is chapter 2, README. But before that, on chapter 2 or chapter 1, we had all the tools needed that has to be installed. So we need Docker, we need kubectl, we need Kine and Helm. So I have all these, but it's just not Docker, because I've switched to Podman a while ago, and I will run the samples on Podman. So wish me luck.
Kind. Running. You mean running kind with Podman, right?
Yeah.
Yeah.
So Podman will
add support. I think it's an extra flag, an extra environment variable that you have to set it, but everything else kind works.
Yeah, should be good. So I have all these prerequisites, and we will be seeing the application in a while, so I'm not going through that. There's nothing much here, and if we need to, we'll have a look. I'm switching to the second chapter. So I need to create a kind cluster, but for this I need Podman running in my machine. Okay, I hope it doesn't take too long, but it doesn't usually. By the way, let me change my resolution if you guys can't see it, right?
You can do a plus one, like command plus one.
Yeah.
Yeah,
is
that's
it too big?
One. That's it. One more. Yeah, it's good. At least for me, I can see it.
Okay. So here, Podman has stored it. So Podman machine init. Okay. So there is a little warning here before diving into the whole book section. I want to warn you about this. So this Podman doesn't have root permissions, and it will not be using some specific ports like 80, port 80 or port 443, unfortunately. So for Podman, if you're using Podman, you have to stop the machine and make your Podman, I had this before, rootful, which means this will now work as root.
Okay. Run the containers as root. Yeah.
Yeah, exactly. Run the container as root. And now let's start the machine again. And then this is like old Docker
And this is
days.
what chapter 2 is, right? Chapter 2 is around like taking the hello world, like not hello world, but the skeleton app, and then try to just run it out of the box on kind. If
Exactly.
you get that far, then the next chapters, then you start building on top of it, right?
Okay. So, yeah, I got this. Now I need to run this command to create a kind cluster with a very specific configuration. So in this configuration, we have 3 workers and 1 control plane. And it also sets some port mappings here for us, but this will be very useful later on. So I'm not going to do like kind create random cluster. I'm going to use this one because the worker. Okay, I still have it. Delete.
Delete cluster dash ndev. Yeah.
Okay, let's do it one more time.
Yeah, and it has the extra argument says no label ingress ready equals true. What that means
Yeah,
is for nginx, when you run nginx, you want to run those pods there. So it's for nginx, so you can have an ingress.
yeah. At the same time, while this is being built, let me switch to the book. So after we get all these, we will be using these.
Oh, he uses an OCI.
Yeah,
Okay. Yep.
exactly. I also so now using Podman, I did not log into Docker actually, but you have to log into Docker IO. So it throws an error saying it can't find the image. So it's a bit confusing. So for this,
But people that are not using Podman, they should be fine, right? It's only brave people only have these problems.
yeah, I just at some point Docker was annoying me because on my
Yeah.
laptop, and I decided to, yeah,
No,
it
this
was
is this
just
is how
not
you
getting
learn,
back.
right? This is
Yeah,
how you learn on trying different things. I
yeah.
have used them all, like Minikube, but Mankind.
Okay.
There's many.
Let's see. Yeah, what we have. Yes.
Yeah, the
So
bots are
we
ready.
have, yeah, we have 3 workers, 1 control plane. Let's go. So it also shows
So for
the
folks, just
setup.
1 minute. So for folks that are trying this for the first time and learning Kubernetes and all that, if you get this far and you go kubectl get notes, you can take a screenshot and just tell your coworkers that you were able to do a multi node
Yeah,
Kubernetes in your laptop, right? That's kind of the
exactly.
benefits also of kind, that you're testing something that it depends on multiple nodes. Kind, that's the benefit of kind.
Yeah. The first time I ran Minikube in my Docker, I was so excited. I said, guys, I'm running a Kubernetes cluster
In your
inside my
laptop, yeah.
container.
So it's for, yeah. I did it 6 years ago. So if you're starting Kubernetes this year and you got this,
Mm,
this is a big milestone, right? Getting to
yeah.
Tinker, and then from that point on, you troubleshoot and you. This is your dev life cycle, working with Kubernetes on your computer.
Yeah, so now we have to load this SH. So it pulls some images for, uh, time issue, like time management purposes, because pulling all these images will take some time. But for me, these need to be all Podman. Yeah, sorry. And probably it won't load in kind, but it wouldn't be a problem. So you
Really?
need to
Okay,
run.
is it kind Podman dash image? I'm surprised that
Oh
that's
yeah,
the
it's
flag.
this is not going to work, but this probably will not work with Docker image as well.
Yeah, that
Yeah,
that
yeah,
that
because I
that
changed all
portion
of
at the
the
bottom
notices.
is
Yeah, yeah,
incorrect. Okay.
yeah, yeah.
And I think I remember doing something in my laptop when I was doing Podman, which is an alias. I just did alias docker equals podman, and then most of the my Docker commands
Oh,
just work, right?
okay.
Because it's an
Yeah, yeah.
alias.
Yeah, actually it might work. Yeah, true. Pod compose works definitely, and I've tried it, and yeah, all that. Deleting, yeah, listing images, everything is pretty similar. So for Docker users, there is a little screenshot here. You need to be aware of your virtual disk limit and the amount of space Docker gives you and the CPU limit. You might need to arrange that, but yeah, for Podman I won't go into that. Oops,
Yeah.
sorry. Then we
And
install the
I want
Nginx.
to highlight something. Like,
Yeah,
some people don't have computers like are this big, right? Or their work computers not this big. But if they have a old machine in their house or a machine, they can repurpose it and install Linux on that machine, and
exactly.
then do all the exercises in there. And then from VS Code, you can SSH connect into that machine at your home, right? Maybe an old laptop or a NUC or something like that, and
Yeah.
that will be your home lab.
Yeah. And if you're on a killer coda type of playground,
Oh
you
yes, yep.
always you won't be able to get the ingress controller working like this, but you can definitely map a port
Mm-hmm.
to another browser tab, and you will be able to access your application through that as well. So I just installed the Nginx Ingress controller. This is the regular setup on kind. Oh, sorry, it always switches. But this will help us access our application from outside of the cluster. So now without having to map my ports, I can get to the application on
From
my
the browser.
browser
Yeah.
from localhost easily. And we can check that with, yeah, it might take a bit more time. So yeah, this
Yeah.
is the
No problem.
exact image is shared here, so I can see that it is working. So pretty good. So let's keep going. Here is the Helm OCI package and how you install it. So this is basically the whole application, conference application is packed in this image as
It's a Helm
actually
chart, right? It's a
it's
Helm
a Helm
chart.
chart.
Yeah.
Yeah.
So something like some people may not be aware, right? Like a container image registry. We used to put container images, and then at some
Yeah.
point, that container registry became not just for containers; it became for all the
Yeah.
assets, like a Helm chart.
Francisco has something to share. Yeah, that was my missing this morning. What happened, I didn't know, but feel free to share. So you can actually find this repository on Docker Hub, by the way, Docker registry.
Yeah. And if you have
And
issues, please put them in the Slack, right, during the week, and then other people that are trying the same
oh,
exercise, you can help each other.
yeah, and the Nginx failed apparently with Francisco. Yeah. Um, so you might need to be aware of your um, containers because because
Oh, cool. It
you
fixes.
can't if you can't port maps if you're working rootless, that would be an issue.
Yeah.
So now let's see if everything's up and running. Yay, so we
They
have the conference app in
everything there.
text
Like we
format.
have
Yeah,
deployment. We have the
yeah,
agenda service. We have even Kafka. Like, you can. This is the other thing that you can brag to your friends or coworker. Like, you got
yeah, say,
Kafka running in your laptop
yeah, you are now you're now dealing with event brokers already,
and
and we
Postgres
have
and
Postgres,
Redis.
Redis, all at once, and we can see here some restarts. That's also important because some of these services rely on Kafka, PostgreSQL, and Redis, and you can see these didn't get any restarts, but these did.
Which
Why?
is
Because it took time for them to start the service. Then once they're ready, the services that actually dependent on them could respond and start it. So
yeah. And then
okay,
I
are
was
you
going to
guys
mention.
ready?
was going to mention a best practice. So the restart
Yeah,
is a best practice. It looks like the app was written in a way that how you write applications, that if you boot up your application and there's a dependency that is not there, you need to exit out so you can restart again. And then by the time you restart, it could be a couple of times. If you write your application that it checks that you cannot connect to a database, and then you just stay there, right? Then who's going to restart your application to again? So you say this is how Kubernetes work: eventual consistency. All the things are deployed at the same time, and then between them they have to resolve the resolution of the dependencies.
exactly. And also there are some other practices for this, like now Kubernetes introduced startup probes, so you can actually get your container waiting for the dependency before actually trying too many times and maybe bloating the
Yeah,
whole dependent service, whatever that is.
yeah, you
So
can
you can,
be, yeah,
if it's a old kind of service that takes
yeah,
time to load, and like if the main container is not working like in a short amount of time, you can add a startup probe there. Okay, enough rambling. Here is the local host in my laptop. So we have our
amazing.
application up and running, and it's actually a really nice
Yeah, this is
application.
a good feeling
It
for
is
a
not
Friday,
like,
right? Usually
yeah,
you spend the whole week working with Kubernetes and nothing works, and then but at least on Fridays you get something working in Kubernetes, even if it's for the book club. That's a good thing.
so I'm not going to take too much time. It is a really fun application to play with. Let's just have a look. So this is a conference application. So it has a service for call for proposals. Obviously this is the front end, but behind the front end it uses the call for proposal service. So let's test this. My first proposal, my first talk. I have no idea. Yeah, let me try
And then
make it quick.
this is an app that you can like use in your
Yeah,
company if you have like internal talks
exactly.
or
That
meetups
works.
or something like that, and you want to have proposals. This is something you can run inside your company, right? And handle
Yeah.
the CFPs for your
Okay.
internal hackathons.
Exactly. And let's see, then there's a back office service. So I can go to that here or here. So here I can review the proposals. Once I review the proposals, I can create my agenda items. So these are the notifications for the proposals. We'll see a bit more about this. And these are the whole events if you want to have a look at them. So I created one new proposal and it created one event here.
That will
And
come up in the book. So
yeah,
if you're liking the book will go over like event-driven applications, and that's called EDA. Is used
yeah,
a lot in a lot of businesses applications where you have events happening. In case this is we're using Kafka with cloud events, and then something happens over here, and then you react on that event and process. So that's why
yeah,
the word events there.
yeah. So I'm going to reject this one because that's a terrible, yeah, CFP summary. So you can also see the notification here.
The email,
So
right? Sent to
yeah,
Sevi. Okay.
yeah. I'll cry a little bit tonight about this, but I'll probably recover tomorrow. Okay, so our application is ready. And there are some cleanup notes, guys. It could be helpful because it has some persist data in here and the volume claims. It explains how to clean up your application properly for the next run. So let me now switch to the book and see where this takes us. Okay, so this is, if I could just zoom in a little bit, this is the
Just
really,
command plus to Word.
Yeah, it's just a
Yep.
bit annoying. So this is the whole architecture of this application. So we have the front end, we have CFP service, we have agenda service, we have notification service. I haven't had a look in the codes, and I don't know which language was used to build these, to be honest. I didn't have a chance. But as you can see, like a platform engineer, I can get the code in packed in Docker images in a Helm repository. I can deploy it somewhere, right? And with proper industry standards. So we have a PostgreSQL that CFP uses, and Redis and Kafka. This will be our main topic for a few weeks. So I would definitely suggest you play with it a little bit this weekend. So yeah, we can interact with it on localhost now that we have the Nginx ingress controller. And it goes through a little bit of the application. And yeah, so you can also see the notifications in logs. I will not go into that because it's
Yep.
basically the conference notification service logs. You can see that very easily. And it's the same message for the email.
Yeah, you show
And we
this.
have events. Yeah, that could be helpful. So to be able to see the events, I think. Oh no, okay. There is also a debug mode for this application. I think we will go to that a little bit later. So here you will be able to see the events Kafka has dealt with. Okay.
Yeah, and I think he's using cloud events, or it's just, yeah, I think he's using cloud events.
Yeah. So from now on, we will be playing with this walking skeleton. So the book takes us to Kubernetes basic components, resources. So let's have a look at one of the deployments. If I can get rid of this. Yeah. Okay.
Yeah, Kevin shared the folder where the code is, so people can take a look at the.
Oh, really? Yeah,
Yep.
nice.
One of
Thanks, Kevin.
when he was developing this app, I remember that I was
Oh,
reviewing
really?
it, and he wanted to do like a combination, like a Go. I think it has Java in there also, because we wanted to use them with Knative. So let me see.
Oops, sorry, typo.
Yeah, most of them are
Let's
Go,
see.
I think.
So which one? Yeah, okay. I picked conference agenda service deployment to just investigate a little bit. So here you will be our strategy type is rolling update, which is our like the way how we manage our releases in Kubernetes, the native way. And these are the replicas we have now. For this deployment, we only have one replica set.
Sebi, there was a question about that. Francisco was asking if he can play with this, like try to break the app and the app continues to work. So
Yes,
we
actually,
want,
this
if you,
section in this chapter we will be looking to this. And if I can't make it, there are really nice ways. Just take the replica set like down to a replica number to 0, for example. What fails? You can
yeah,
see if the application can serve. So in cloud native applications, one of the challenges is not like a monolith application. You want it to still serve, but if one of the components in your application is failing, either give some proper explanation and error to your customer client,
yeah,
or maybe have some sort of caching to fill that information.
yeah,
So in the meantime, in the background, your application should be healing itself by Kubernetes capabilities. And if you're not doing this, you're actually not using Kubernetes functionalities. We can say that.
yeah. I'm increasing the number of replicas. So if you, in a
Yeah.
deployment, if you have one replica and you shut it down, then your app will be down until that pod comes back up. But if you have like more than one replica, two, three, four, then requests are coming in. So that's how you update, and that's if you kill one pod, there'll be like the other ones will handle the load, right? So
Exactly.
the app will not be down.
So here you will see one agenda service container. This is the name of the container, and the container in the spec, you will see the image name and the port and the liveness readiness probes it has, and the environment variable. So with this environment variable, it actually connects to Kafka, with to Redis, and yeah, you can play with these, and you can even download the Helm template and also change that and redeploy, and then see, how the application responds to those changes.
Yeah, you can do
So
a if you want to grab a copy, you can do Helm pull instead of help install. You can do Helm
yeah,
pull the URL OCI, and then we give you like the tar file, the Helm chart, and then you can like deploy from that folder, like Helm install dot, and point to the folder, and then
yeah, I think
deploy
it was
locally.
somewhere here, but I also
I think I
tried
saw it.
this.
Yeah,
Yeah, it just pushes the whole Helm charts as an exempt as well.
yeah,
So now we've checked one of the deployments. Yeah, so as you can see, we talked about the replicas, we talked about the container image, environment vars, etc. Let's go to replica sets. Yeah. So let's see how resilient this application is. So the replica sets are about how many copies of your services you have in your cluster, right?
yeah. And replica says something that you don't create; they get created by the
Yeah,
deployment.
yeah. Um,
Go, yeah,
I don't know if you can hear this. Someone randomly started throwing fireworks in my
oh,
neighborhood,
fireworks.
like
Okay,
it's
I got
like it's
scared for a
New Year's.
second. Okay, I
Nothing. There's nothing wrong.
okay.
It's just some random person. Okay. So yeah, everything here has just one copy, so it wouldn't make us too resilient to problems, right? If one of the pods will have an issue and it goes down, your application might have issues.
Yeah, what I was going to say is,
Let's change
folks,
it. Yeah.
when they start working with Kubernetes, they only see the deployment, but actually the deployment creates a replica set underneath. So every time you upgrade the application, the deployment object creates a new replica set definition.
Yeah. So there's this funny thing I learned about Dutch culture. They really like fireworks during New Year's. It was very traumatic, my first New Year celebration here. It takes, I don't know how many hours, like probably the whole day. They throw fireworks.
So you're increasing
And
the replica count to
yeah,
right with kubectl scale.
yeah. So as you can see, now this is the front end deployment. And now I have 2 replica sets for this. So I managed to get this up. Oh yeah, there is a nice feature in the application. I really want to show that to you guys. So you can actually debug mode enable in
Ah,
this application
with
to
environment variable.
see, yeah, with an environment variable in the front end. Um, and once you do it, you will be able to get a bit more visualized version of what we see here. And also it has a little trick with the with one of the services. I can't remember which, but I'll show you now. Yes, so I've changed the debug enable to true.
So put the pods are now
Yeah,
in debug
I'll
with debug
actually,
mode, right?
exactly. This one at least. So you go to about, no, not about. the back office. And here you can see the debug tab.
Ah, see, nice.
So now we've taken the front end replica set to 2. It should have
This is super
one.
useful. Every app should have it out
Yeah.
there. Me as an admin, to know which version is the one that we have live in this region versus that other region,
Oh, let me
an IP
see if
address and
I got
everything.
this right. Now, so I got two. Okay, what did I do?
Yeah,
I have
two replicas,
conference.
and we saw the two replicas.
We saw 2 replicas,
Yep,
right?
two pods.
Okay. Let's see if they're still there. Mm, there's a third one.
Yeah, it says 222, right? Desired to, current
Oh,
to,
this is
and ready to.
probably when I change the environment variable,
It
it is
created a
trying
new.
to, yeah, it's trying to create the new one.
It created a
So,
new. In Kubernetes, it's called revision. So it created a new revision of your
yeah,
deployment, and for every revision of your deployment, a new replica set gets created,
yeah,
and then does the rolling updates.
that's the rolling update exactly. Let's give this a bit more time. Once it is deployed, there will be a nice feature you can see, but not now, I reckon. Yeah, it will be every 3 seconds. It will be changing. Oh yeah, here, as if you can see, it's changing which front end actually responds. So you can see now the pod
See, that's
changes,
it.
pod
Yep,
IP changes here.
yep,
Oh, by the way, let's also have a look at the node. Not this one yet. So how the pods are actually spread around the nodes. So you can also see, all 3 nodes are taking pods now, and I'm expecting some, tainting in the upcoming chapters,
yep.
so we can manage the whole, thing, and maybe we can take a worker down and the rest of the application still is on, right? So it's an important feature in Kubernetes that your application still runs while you're maintaining the infrastructure.
Yeah, what we call resiliency, right? The
Yeah.
resiliency.
And let's see. Okay, how much time do we have? 10 minutes. I think it's good. So, yes, it also looks into services. So, if you want so you can have one pod running somewhere on its own or in a deployment, but you should be able to get these all working in an interconnect manner. So, you will need services for this. Let's have a look at the services here. Okay, we have the Kubernetes service itself, and then the rest of the services here. So they have some specific ports. Some of them are on port 80, and they get some IPs. But be aware, these IPs will be different than the ones here because these are
Yep,
pod IPs. So your pod IP, so the services will select the pods in their definition, and we'll try to find those pods within the service definition, and then we'll map all those IP. We'll actually route traffic into those pod IPs that actually matches that labels.
yep. And there's an object between service and pod. It's called endpoints. So, Sevi, can you run the same command with, instead of
Oh
service,
yeah.
called EP, the letter EP? And that's no, instead of service, get the
Oh
EP.
yeah. I remember this
So if
one. Yeah.
you're an admin trying to troubleshoot why things are not connecting or the service doesn't have any pods or IP addresses, it's because the the selectors may be wrong. So this is a way to troubleshoot that, like
Yeah, so
the
this helps
endpoints,
you definitely understand which endpoints this service is pointing at.
IP and
uh,
port combination.
IPM port. So I scaled up the front end, so now you can see two
Too.
different IPs here.
And then when you are in a cloud provider, sometimes these are the endpoints that get configured to the cloud provider load balancer. And then the connection goes from your browser to your cloud provider load balancer, and from the load balancer directly to those IP addresses.
Let's now have a look at service discovery a little bit. So this was handled by the ingress here. Well, everything, if you want your applications to be accessible from outside of the cluster, you will need an ingress resource.
Yeah.
And let's check how our ingress resource looks. So we only have access to the front end, right? Because every time I hit localhost, it goes to the front end. And let's see how this is described as an ingress resource. Ingress, I would do back here. Yeah. So now, as you can see, it is using path, and it is mapped to the front end 80. And it is using hosts, all hosts, let's say, for this.
To any traffic, HTTP
Any traffic,
that hits there gets routed to.
And it's also using this address.
Yeah.
So there's the explanation of this. By the way, there's another great resource I want to share from the book. So it's the comparison of all Kubernetes ingress controllers.
Yeah, from the Learn Cakes research.
Yeah.
Yes.
Brilliant, isn't it? I was not aware this existed, and I was like, what? When I'm reading this book, now I'm bookmarking it.
Yeah, and
so once you have a problem, you can test internal services. You can use the endpoint feature as well, flag as well. But you can also port forward one of the services to understand, like, okay, if your front end service is fine, but there's something wrong in the back end services, right? You can also check this by port forward command. This is very helpful when you're an admin somewhere. So you need to keep this terminal open, and maybe curl if this application responds to it. Yeah. So as you can see, the agenda service responds to curl, so it's up and running. But if I take it down, it will probably not return to anything. But I would still have my front end up and running, and I would be thinking, okay, what's wrong? What's happening with agenda? You can also check the pod and the Kubernetes resources health as well, obviously. Oh, I didn't do the color output for you guys. Sorry, I was a bit lazy. Okay. So let's have a look at the challenges. There are a bunch of challenges which actually will require you to play with the application, and that is super fun. I definitely recommend you try it. Homework.
Section 2.4 is homework for people.
Yeah, so you can scale up the front end. So then, as we tested it,
we have
front end with the debug mode on will be scaled up. Right now, you will have this. Why would you need it, Carlos?
2 pods.
Scaling up. Why would you need scaling up your front end, for example?
One
in a real world scenario.
The first one is upgrades. So you want to upgrade the version, make upgrades to your application, right? The next version application. So you need to do a routing update. So the deployment service needs to rotate your version, so it takes one down, it takes the new one up and then new one down. So it avoids that.
Exactly. Yeah.
And then the
You might
second,
need to handle traffic, like more
and the
traffic.
second and the
Yeah.
second one is there's the HPA, the horizontal pod autoscaler, that
Yeah.
you can configure the deployment that when in CPU or metric, then you will have more pods if there's a lot of people visiting the website during CFP. And then when there's not that many people visiting the CFP because there's already the deadline passed, then the traffic goes down, and then you have maybe one pod or two pods.
Yeah.
So it's auto scaling, right? To be able to not waste money on having a lot of pods and VMs around.
Mm-hmm. Yeah. And be aware also, I think it will come up in the later section, but be aware that the agenda service, for example, is persistent, right? I can't remember if it was using Redis or Postgres, but you need to be aware the number once the number of services here goes up, you have to take care of the connection limit on your databases as well. So you might need to fix that as an environment variable or scale up your databases, whatever. The
Um, there's a question in the chat from Maz. This is a good one. I think what's better practice, to two pods in two nodes or two pods in three nodes? So that's a resiliency kind of question. So what you want to have
Mhm.
is have pods in different nodes, because when you shut down one node, the other, you guarantee that there's a pod in a different node, and you do that by doing anti-affinity. And one way to configure that, you can see that in the Kubernetes docs, is an anti-affinity that says, I want a pod on this node, and if there's another pod to be scheduled on this node, please don't I prefer not to put the same pod again in the same node. Try to find another node. But if you don't find another node, then put it here. So you can have a prefer or required, saying anti-affinity. If it's another replica of myself, I don't want it in the same node as me, because if we two pods are in the same node, we go down, like there's no other, the pod is not there, there's no replica nowhere else, right?
I
So
was
let's go
going to ask if you're
anti-affinity.
going to annoy yourself.
Yeah, it's enough
Okay.
for one of me, right? I don't want two of me in node. Something that you learn, like kind of like level of 100, you like deploy pods and get it working, and then you work on resiliency, right? On spreading that. It's the same thing that when you scale from zero the nodes, and you have maybe a Kubernetes cluster, zero nodes, and you come up, you want the pods to be spread evenly among the nodes. You don't want all the pods to land in one node and the other nodes have zero pods.
Yeah.
Good question, Maz. So we encourage questions.
Yeah. I'm not going to try this one,
No,
but
I don't think
you
that we
can
have time
check.
to try, and we're almost done.
Yeah, I also don't want to ruin all the fun
Yeah,
coding part for people. Um, yeah, we're almost done, right? Yeah, so definitely try these chapters, extra the all the sections here. So it will help you understand what a resilient cloud native application should look like. And it
yeah.
also touches monitoring. It also touches authentication and authorization as well. So I think in the upcoming chapters we'll be dealing with those.
And
So
the last section here, you can put the picture of figure 233. Is the last picture of this chapter. It talks about how this links back to, if you scroll down to 233, the last picture.
233, 233.
Um, yeah, it shows like how this links back to platform engineering.
Oh yeah, this one 2.5, I think.
2.5. Yeah, go down. There's a picture.
Yeah.
I don't know where it is. Yeah, this picture. So this is how Mauricio is linking back to
Yeah.
platform engineering, because the idea is the application is composed of four, let's say in here, four microservices. So if you're working in platform engineering, you are maybe going to have four teams in your organization: the team that works on the front end, the team that works in the agenda, the team that works in the service, the team that does the notification. There could be like different teams, and all of them have their own CI/CD pipeline, and they have the release versions at their own cadence and fixing bugs. So you, as a platform engineer, you need to build a platform that you can satisfy all the
Yeah.
teams, and they all they work together. They're all working with the same standards that you put in place of, this is how we're going to deploy every service. We're going to do test and build. We're going to package it. We're going to bump the version of the Helm chart and then deploy the front end. So I think Mauricio deployed the app as a single Helm chart, but that Helm chart is kind of like a mega Helm chart composed of small
Yeah.
Helm charts. But
Every service.
every
Yeah.
service is individually can be updated and maintained, right? And it could be that you have one Kubernetes. I've seen this in production. You have one Kubernetes cluster for Kafka and the databases, and maybe Redis, like the stateful workloads, and you do upgrades in place. And then you have a different Kubernetes cluster for the stateless services, the Go code, the JavaScript, and the service, and you have a different Kubernetes cluster, and that one maybe you do blue green, for example, and
Yeah.
then you divide stateful workloads goes in this cluster, and this other one goes in the other one.
Yeah. Before closing, maybe there is a question about the topology spread constraint. The last question.
But the topology constraint, I think that was newish.
I haven't
Feature of
used it.
Kubernetes that
Let me
also
see.
takes account into I think zones. You can even put like domain. I think it uses domain mean domains. So yes, that also takes into account. So for example, I know we're running out of time, but if you are in the cloud provider and you have different availability zones, you're running in a region with the cluster, and you have an availability zone of like one city versus another city, and one city there's a fire, right, or something like that. Then you want to have those pods. You want to have enough pods that are like available in this city and this other city, because maybe there's a city, there's a fire or electrical problems or something like that, and then the other city, the other availability zone, you want pods over there. So this is something that allows you to do a max queue and the min domains, like domain of
So it's like a
resiliency.
range of numbers, is it?
Yeah, and then the max queue of like telling the scheduler. So there's many ways that's also associated with node affinity policies and such. But yeah, it's a whole chapter. People spend their time sometimes just working on resiliency, right, for Kubernetes. So it's more than just saying add one line to the YAML file, right? But yeah, that's correct. Who was that said? Olan. Yeah, Olan should also be considered in terms of resiliency. Yeah, you can see the section in the docs that says no labels. Like you will label the node saying this node is located in region US East 1 and zone is US East 1A, for example. So when you spread the pods, you take into account those regions and zones, or the zones more than the region. Good question. Chapter is a mention of OpenTelemetry.io. It will be possible to share any suggestion how to include this in this project. I don't know. We'll ask Mauricio will come back. I think he was out today. Next week, I think he'll be able to make it next week. But I think monitoring is covered in the chat in the book.
Yeah. I haven't had a chance to check if
observability, right? How
points
to
are
do observability.
working.
Yeah, but the short answer is, will it be possible to do OpenTelemetry on this project? Yes. Like OpenTelemetry is around logs, metrics, and traces, and it's basically collecting those from these pods, and then yes, that's possible.
But I reckon when we did all white, there was nothing else. So I think in the walking skeleton, there's nothing yet.
No. Like the walking skeleton is the walking. This is not running yet. It's just walking. The skeleton is just walking. It's just pods.
Not
and
ready to scare
like,
you.
we don't have OPA or Kernel. We don't have
Yeah.
Prometheus. We don't have Open Telemetry. All those things
Yeah.
for day two operations. We just wanted to have people to run the app and be happy about it, not worry about why Open Telemetry doesn't work, and Prometheus is you cannot open the Grafana dashboard and get frustrated about that. So it's steps to get there. So any final thoughts, everybody? So far, feedback. It's always good to get feedback. You can put it in the chat if you like
Yeah. Thanks
the
for bearing
meetups.
with me because I was really
No,
sick
you
this
did great.
Friday.
I wasn't expecting any demos, so this is fantastic.
No, that's super fun. Playing with this application. It's been super fun. Yeah, I was just sick, so I don't know. I
Oh, sorry
managed to
about
finish
that.
it without coughing.
Sorry about that. Feel better, Sebi.
Yeah,
So
I'll
yeah,
stop recording now, guys. Thanks for joining.